Hi again, everyone. So we are moving on to part 2 of the 2014 paper 1 for BJC Mathematics. And in this particular segment, we are going to go through questions 7 through 12. So let's begin. Okay, so question 7 is in 2 parts. We have a part A and a part B. Part A, we have a diagram here, and it asks what fraction of the diagram is not shaded. So we first need to identify what are our non-shaded portions, and it's all the white boxes. We see we have 1, 2, 3, 4, 5, 6, 7 of those. And of course, we need to know the total number of parts. So how many total parts do we have in this figure? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our answer, unshaded parts is 7, total parts is 10. So our fraction is 7 out of 10. Moving on to the next portion of the question. That asks us to express the shaded part as a decimal. So let's identify how many shaded parts we have. We have here all the gray boxes, 1, 2, 3. And again, we know that the total number of parts that we have is 10. So we can first write this out as a fraction. Shaded parts is 3. Total parts is 10. Our fraction is already in base 10. So we take our numerator, stick it behind the decimal point, and that gives us our decimal value. Okay. Moving on to question 8. We have 2 numbers, and we're given their prime factors, or they're given in prime factor form. And so the question asks us, what is the LCM, or the lowest common multiple, of our 2 numbers, 8 and 12? So to find the LCM of a pair of numbers or a group of numbers, we first need to identify a group, or all the groups of factors that are common. In this case, we have a common group of 2's and another common group of 2's, but we don't stop there. For HCF, we would stop there. We don't stop there. We also want to make sure we include our stragglers who do not have a matching pair. So we have a 2 that doesn't have another matching 2 in our second number. Likewise, we have a 3 that does not have a matching 3 in our previous number. But we want to make sure that those are included. Then what we do is we take each of the circle values and we multiply. So in this grouping, we take 1, 2, we write that down. This grouping, write down 2 to represent that group. We write down the other 2 from the straggler group to represent that. And then likewise with the 3. And then we multiply all of these factors together. So 2 times 2 gives us 4, 4 times 2 gives us 8, 8 times 3 gives us 24. So our LCM is 24. Question 9 says, how much greater than 3.93 is 7.24? So when you're doing a comparison like this, greater than another value, that's a subtraction problem. So we pretty much set up our problem as a subtraction problem and solve. So the larger number goes on top, that's our 7.24, subtract our 3.93, and basic subtraction, 4 minus 3 is 1. We can't take 9 from 2, so we borrow 1 from our 7. 12, take away 9 is 3. When we borrow 1 from the 7, we're left with 6. 6 minus 3 is 3. So our answer is 3.31. Okay, question 10. What is the square and cube of the given number? So we're given a number 3. And the square of a number is a number multiplied by itself. 3 times 3 is 9, so the square of the number 3 is 9. The cube of a number is a number multiplied by itself 3 times. So we have 3 times 3 times 3. And this is actually incorrect. This should be 27 and not 9, as it states here in the question. So let's just go ahead and correct that before we move on. We're going to make that 27. Okay, sorry for correcting this here. Actually, what we're going to do is we're going to take out the answer and leave that for the next page. Okay, so we go ahead, save that. We go back to our presentation. There we go, nicely cleaned up. And there's our answer. The squared is 3 times 3 equals 9. Cubed, 3 times 3 is 9, times 3 is 27. Again, we want to have a good command of our multiplication so that we can easily multiply our values and find our answers. Moving on to question 11. Now we're given 4 fractions and we're asked to order them from least to greatest. So we're comparing. And in order to successfully compare fractions, especially in this case where our fractions have different denominators, we need to follow some steps. The first thing we want to do is we want to find the common denominator of all of the fractions, right? Basically, to solve for this, we're going to convert each fraction into an equivalent fraction that has the same denominator. So, step 1, find the common denominator for all fractions of all of our denominators in the fractions given. And that common denominator is 12. Next, we're going to convert each fraction into an equivalent fraction with the denominator 12. So let's see what that looks like. Okay, we have, remember our fractions, 1 over 2, 5 over 6, 2 over 3, and 1 over 12. Okay, so 1 over 6 to create the equivalent fraction with a denominator of 12, we multiply both numerator and denominator by 6. Doing so gives 6 over 12. Likewise for 5 over 6, to get a denominator of 12, we multiply our original numerator and denominator by 2. So we get 10 out of 12. For 2 over 3, we're multiplying numerator and denominator by 4, gives us 8 over 12. And then 1 over 12, we already have the denominator that we're looking for, so we don't need to do anything with that. Okay, so now if we write our original, or write our equivalent fraction, and then place the originals underneath, we see how they line up, okay? So that is how that's going. So we're on to question 12. This is the last question in this particular segment. And let's read it. It says, a circle has a diameter of 14 centimeters. Calculate the area of the circle. And the question gives us the value of pi, which is equal to 22 over 7. Now, in order to solve this particular question, we need to know how do we calculate the area of the circle, or what is the formula for the area of a circle. So the area of a circle is equal to pi r squared, and that's why we were given the value pi. Pi is equal to 22 over 7. Now, if we notice, our question doesn't give us an r, it gives us the diameter of the circle. But once we know the diameter, what we can certainly do is we can go ahead and we can find out the radius. The radius is equal to half the diameter. So if we divide the diameter by 2, we get our radius, which is 7 centimeters. So now that we have all our values, we can go ahead and plug them into our equation for the area of a circle. And, excuse me, this should say the formula for the area of a circle, and not an R of a circle. Let's save that and go back. Okay, that looks better. The formula for the area of a circle is, okay, and we plug in our values. Now, R squared is the same as saying R times R. So our formula can also read pi times R times R. What is pi? Pi is 22/7. What is R? R is 7. And then we multiply by another 7. So notice we have a fraction, and we can certainly go ahead and cancel the denominator in our fraction with one of our 7s. That gets rid of that. We're left with 22 times 7. And if we multiply 22 times 7, we get 154. And do not forget your unit of measure, which is centimeters squared. Let's make sure that's, yes, it's in centimeters. Good. Okay, so that concludes our second segment of the BJC Math 2014 Paper 1. We will see you in the last segment, segment 3, where we cover questions 13 to 18. Ciao, ciao.